In lesson 54, we're looking at polar coordinates and similar triangles. In the first example, it says to change 4 57 degrees to rectangular coordinates. So this has a magnitude or length of 4 at 57 degrees. Let's look at it on a graph. That might help. So we would go from the x-axis over 57 degrees, and then it had to have a length of 4 to the point here. So that would be 4. Okay, so this is polar coordinates. So to make that into rectangular coordinates, you can think about that being in a triangle, and this would be our opposite side, and this would be our adjacent side, and then this would be the hypotenuse. And we need to find what this length is. This is like a y, and what this length is, it's like an x. So what we do, and I just recommend memorizing how to find them. You could go and set it up every single time and find the missing sides, or you can remember how to set it up. See, this is going to be for my x value, which they label as an r, and the y value as a u. Okay, and I think they just give it a big U. Yes. To find, say if I want to find the x value first, or this r, it would be 4 cosine 57, which would equal 2.18 r. And then to find the y value, it is 4 sine 57, which equals 3.35 u. Okay, now when you see this written out, it's like a addition or a subtraction problem depending on the sign of the y value or the u value. This is 2.18 r, and they're both positive because this is in the first quadrant, plus 3.35 u. Now if you need to see how this is set up first, this would be cosine 57 equals x or r over 4. That's why I just needed to multiply by 4 to get this. And then for the sine, it would be sine 57 equals y or u, or whatever variable you want to use there, over 4. So again, I just multiply by 4. Okay, so I just go to that standard format every time. It's the hypotenuse times cosine of the angle for your x value, which is either right or left, and then the hypotenuse times sine of your angle for your up and down or y value. Okay, or they have the u next to it to represent that in the Saxon book. And you will see that in other formats later. Alright, example 2 is change 7 at 230 degrees to rectangular coordinates. So, again, I think it's helpful to see this on a graph, because we're starting from the x and we're going counterclockwise. So that right there would be 180 degrees. And then we would go enough to make this angle add up with 180 to be 230. So this needs to be 50 degrees. So this whole thing here is the 230 degrees, but this right here is only 50 degrees. Okay, and you could just make your triangle, and this would be your opposite, and this would be your adjacent, and you could use the 50 degrees with that triangle. Now what I do is I just use, again, that 7 is right here. It is like a hypotenuse. So if I went 7 cosine 230 degrees, I will get negative 4.50. And I'm rounding to the hundredths place here. Okay, and then I'll go 7 sine of 230 degrees would equal negative 5.36. Now you'll notice there's signs. This should be a negative and negative because we are in the third quadrant. And the x would be negative and the y would be negative there. So they give the x an r, or that is the right and left one, and they give the y a u, which is the up and down one. So when we write this out together, we'll go negative 4.50 r minus 5.36 u. Alright? Then on our last example of changing to rectangular coordinates, we have a magnitude of 42 at 340 degrees. Okay, so this goes all the way around here until about so. And this is 20 degrees as our reference angle if you wanted to use that. And this all the way around here is our 340 degrees. So this would be the opposite, this is adjacent, and this is the hypotenuse, the 42 is. So we go 42 cosine of 340. So this, it's in the fourth quadrant, is positive, but down here the y is negative. So our sign should give us a negative number. So for the r value, we have 39.47. And then we have 42 sine 340 degrees, which is negative 14.36 u. So when we write this out together, we'll have 39.47 r minus 14.36 u. And then that would be our answer. Okay, and then on 54b, it doesn't really give this exactly as an example. It just kind of shows a demonstration and walks you through it. But to solve these, you start out making the ratios. Like a and b, they are related sides because they have the same angle that they're, or the same two angles that they're between. So I could say a over b would equal c over d. And then if I wanted to solve for one of the variables, I would pick out which one I wanted to solve for. Say if I wanted to solve for a, you could use cross multiplication and divide, or I know that I would just need to multiply both sides by b. So that would cancel here, and then a would equal cb over d. Alright, but say if we wanted to solve for a different one, let's say or A over B equals C over D. What if we wanted to solve for one that was on the bottom, like if I wanted to solve for D? We'll use our cross multiplication. So I'd have AD equals BC. And since I want to get the D by itself, then I would divide both sides by A. So then D would equal BC over A, and that would be my answer. So you just set up the ratios like we've been doing, except this time you don't have any numbers. You're just going to get that variable by itself. Hopefully this is helpful, and I will see you in lesson 55.